Hi, this is a short video showing you how to use Delta version 5 to process simple proton NMR spectra on your computer. I assume that you already have loaded Delta onto your laptop or your computer and are ready to use it. You need to acquire a spectra on the NMR spectrometer, and typically we then email it to ourselves. So you'll need to go to your email program and download the spectrum and save it on your computer so it's ready to be processed. The biggest problem we have here is that sometimes students change the file name, and if you change the file name when you're saving it, for some reason Delta won't be able to open it anymore. So when you download it from your webmail or your mail server, be sure to save it with exactly the same name that it came with. So I'm assuming you have a spectra that's ready to go. I'm going to use ethyl acetate here, and so I've downloaded ethyl acetate into a file on my computer. You can see that the Delta files have a .jdf suffix to it, so that's how you'll know if you actually have an NMR file. And I'll just go ahead and double click to open up the NMR processing program so that I can see it. When I do that, I typically will get the spectrum displayed in the window already processed and ready to start analyzing. If that is not the case, the other thing that often happens is that you'll have displayed a FID above it. So let me show you what that looks like. If I go under Options here and I select Show FID, you might have a display that looks like this, where this is the raw data and this is the processed NMR data. I'm not going to talk about how you go and process the data and convert it from the FID into your spectra. That's sort of a little more advanced technique. This little processing tab here actually can bring up and show you kind of what it's done by default. And there might be reasons later on where you might want to get more sophisticated and use that. But for right now, we're just going to go ahead and use the default processing. And I'm going to go ahead and turn the FID off so that I can see my spectra full scale. So the next thing that I want to do after I get it displayed is I might want to zoom in and look at various regions. So right here are a bunch of cursors that will do different things. In the left-hand one that looks like a little magnifying glass is to zoom in. So if you click on that cursor and you click and drag in this gray area at the bottom, you'll zoom in on a certain window of the data, and I can just keep doing that and zoom in. I can also do a vertical scale by zooming on this axis. And I can even do a click and drag to make a box to zoom in on. So there I've zoomed in on this quartet. Now let's say I wanted to go back. There are a lot of different keyboard commands that'll do things that you might not know what they are. So over on the right are these little key shortcuts, this little K, and if I hold it down, it shows all the different sort of key shortcuts. So for example, unzoom is the minus key, and that'll just undo the last zoom. So I can just hit the minus key, which is what I'm doing on the keyboard now, and go back where I started and sort of work my way back. So let's say I zoomed in and I wanted to go back, I could just hit the minus key. If you ever get lost and you just want to see the full spectrum, you can do that by going and saying Reset View, which would be the home key. If you've got a PC, my Mac doesn't have a home key, so I have to do that through that shortcut there. Okay, so here's the spectra that I've gotten off of the NMR, and the first thing that I'll want to do is set the reference. So remember, we typically reference the spectra to tetramethylsilane. That's what this little peak is. You can see it's not exactly at 0 now, and you can see that better if I zoom in. So I zoom in on my TMS, and here you can see it's at like minus 0.03 instead of 0. So I want to reset that. So there's a little cursor for that, this little cursor that has the 0 in the middle with the peak. If I click on that and then just click near the top of that peak, it'll set that to 0. So there it is, set to 0. Now if I go and I look at this little options tab, it'll actually allow me to put in whatever value I want to set that reference to. So for example, sometimes you might not have TMS in your sample and you might want to set the reference to some other peak, let's say a residual solvent peak. So for example, in deuteryl chloroform, there's a little residual chloroform that comes at 7.26 ppm or something like that, and I might want to set that. Let me just sort of show you that really quickly here. If I go back to the full spectrum, you'll see this little peak right down here is the deuteryl chloroform. Let me use my zoom key to zoom in on that. So there it is, and if I said, oh, I want to reference that to 7.26 ppm, I could just come in here and write 7.26 0.26, hit return, and then go over and get my reference, and that set it to 7.26 ppm for the residual chloroform peak. So you can basically set it to whatever you want. Let's go back and reset it to TMS since we have that in the sample. So again, go back to the full view, get your zoom cursor, zoom in on your TMS, set that to 0. Let's go ahead and set the reference to 0. There's a little button here that'll just set it to 0 for me, and then I'll get my reference button and click right on that, and it's set to 0. So that's first thing. Now I know everything's referenced correctly. I'll go back to the full scale. You can see now that the TMS is right on the 0 like we want. Okay, my next job might be to put an integral on this. So what I'm going to do is I'm going to use my zoom cursor, and I'm not going to zoom in on this region or the TMS. I don't necessarily want to display those. I know what they are, and they're not important in my analysis, so I'll zoom in on this spectra. This is the spectrum of ethyl acetate, by the way, so it's got an ethyl group. You can see the triplet and the quartet down here, and then the singlet for the methyl group next to the carbonyl. Okay, so now let's say I want to put an integral on this. There are a couple ways of doing this. There's sort of a default way in which you just hit this button, it'll automatically do the integration. That I'm not really happy with the results a lot, so I use this manual integration button right here. It looks like a little integral key, so I click on that to select it. And now I'm going to click and drag in the gray area underneath here from the left side of the peak over to the right side, and you can see it puts an integral right on my peak there, and I can go click and drag in any region that I want to make that integral for all the peaks I have. Here's a little water in here. I could put an integral on there, but I'm not really interested in that. But if I did, I could put it, there would be that tiny little integral. By the way, if you decide you don't want the integral, you can always just, when it's selected, hit the delete key. And so you can select integral by just clicking on it and then hit the delete key. So if I didn't like the way I integrated, I could come back and integrate it again. You can also adjust the height with these and move it up and down. So let's say, oh, I don't want it there. I can sort of move it up so that it doesn't start on top of my peak. So you have ways to adjust what the integral looks like, to suit your preferences. Okay, so now we have the integral, and these are just sort of arbitrary numbers that are accurate relative to each other, but don't have any meaning in and of themselves. But let's say we know that this is ethyl acetate, and we know this singlet is 3 protons. We can actually set that to be 3. So I'll select that by just clicking on it, and then I'll go over here and see where it says normal. That means normalize. I'll set that to 3, so I'll hit 3 and hit return, and now you can see it's reset that integral to 3. The other methyl group also comes out almost exactly to 3, and the methylene, the CH2, comes out as we would expect to 2 protons. So that's a really nice way, if you know how many protons you have in a certain peak, to go sort of get it normalized for everything, and works out pretty slick. So now we've got an integral on it, we've got a nice spectrum. We might want to print that out, might be the next thing that we would do at this stage, and I can just print this little print button right here. I'll hit the print button. Now, when I print on my Mac, I usually like to print to a PDF, unless, obviously I can print right to the printer, but if I can save it as a PDF, I can give it a new file name, or anything else. I'll get rid of the .jdf. It'll automatically put in the .pdf, and I'll just save that spectrum. I've already done that, so I'll replace that. And there we go. There's my spectrum. It's saved to a PDF that I could import into a Word document, or alternatively, I could have just printed it out to the printer and had that, to put in a file in my folder or something like that. Now, once you're done with the integral, the next thing that you usually want to do is zoom in on peaks and get a peak listing so that you can report this in a form where you know what the chemical shift of the peaks are, etc. So I'm going to go ahead and delete my integrals by just clicking on them again and deleting them. Okay, and so now I'm back to my normal spectrum. So let's say I wanted to just sort of get a listing of these peaks. The first thing I need to do is set a peak threshold. So that's this little cursor right here. It looks like a spectrum with a line across, and if I click on that, it'll put a line across, which I can't really see here. But if I move my cursor down, you can see it turns a little bit to an arrow with an up and down arrow, and I can pull that up and set a peak threshold. only the peaks that are above that level will be detected when I do the peak pick. So now to do the peak pick, it's this sort of little stop sign shaped thing with an X through it. If I click on it, it will immediately label the peaks that are above that threshold. So there I go. I've got my 3 peaks of my triplet. Here's my singlet at 2.048 ppm, etc. So that's really useful. You know, I might want to write those down in my notebook, or I can print them out. Also, if I go up to reports, there's a print peak list, so I could print them out as a peak list or make a peak report. Typically, what I might want to do is look at them closer and get coupling constants. Now notice that my axis is in ppm and my peaks are also in ppm, which is useful, but sometimes you want to get the coupling constant, so you'd like to have your peaks in hertz. So to do that, if you hold down the command key and click and hold down, the control key, and click and hold down, it'll bring up a submenu, and you can go in here and there's lots of different things you can change. We would want to display the units. We want to change them to hertz, but we don't want to display if we change the display units, notice that both the labels, peak labels, and the spectra have turned now into hertz. You have to look a little closer. They're actually in kilohertz, so this is actually not 1.6 hertz, it's 1600 hertz. And same thing with this. This is 1637 hertz because it's displayed in kilohertz. But oftentimes you would want to have the axis in ppm and your peak pick in hertz, so you can do that. So again, if I hold down the control key and click in the window, I can select display units, and let me go ahead and select the display units back to ppm. So now you can see they've gone back to ppm. I'll hold down the control key, select again, and this time I'll go down to display units, and then there's a submenu under there which is peak units. And so I can make the peak units be in hertz while the display units are in ppm. So you can see this number here between 2.0 and 2.1 ppm, there's a peak, and it's at 819 hertz, because that's 0.819 kilohertz. So that's one way you can get the hertz if you were going to go and get your coupling constants. Unfortunately, in this case, I don't have actually as many significant figures I'd like, because I'd actually like to have it down to 1/10 of a hertz resolution. So there's some ways that I can analyze the coupling constants a little easier. So I'm going to show you that. I'm going to go back to my zoom cursor, and I'm going to zoom in on this quartet. So I'm going to zoom in on that, and you can see my peaks there. And what I'm going to do is I'm going to actually manually select peaks and calculate the coupling constants between them. And so you'll see this is really convenient. So the first thing I'm going to do is I'm going to select my cursor that allows me to pick peaks. So that's this little kind of square box with a dot in the middle. And if I click on that and I click on a peak, it'll actually select it. So what you can do is you can see that it's now changed the color of this one. So I've selected that peak. If I click on another peak, it'll select that one. But now what it's doing is it's selecting one and deselecting the other. So if I want to select 2 peaks that I want to figure out the coupling constants for, let's say I want to take that peak, then if I hold down the shift and the command key simultaneously and click on the second one, it'll select that second peak. Another convenient way to do this is to use your selection tool right here. And if I click on that and I click and drag here, it'll select all the peaks that I've covered. So I clicked from the left of this one to the right of that one, and now these 2 peaks are selected. So once I have 2 peaks selected that I want to get the coupling constant, I can just hit the J button on my keyboard, and that's for hertz. If you forget what that is, if you hold down the key commands, you can see there's a J coupling command where the letter J is there, so that tells you what you need to do. And so there it tells me that that coupling is 7.33 hertz. So that's very convenient, and I might say, well, I wonder what the coupling constant is here, so I'll select my peak. Well, actually, I'll use my select key again because that's select. I'll select those 2. Now it's unselected these and selected those, and I can hit the J button again, and it tells me that the distance between those is 7.1 hertz. In theory, they should be exactly the same, so that's just sort of a little indication of the error in the resolution of the spectra. So I can select any 2 peaks then by using my select key and clicking and dragging if they're next to each other, and then hitting the J button to get the coupling constant. If I want to deselect or have them go away, I can click on my selection cursor, click on the middle peak and hit the delete key, and now I can just delete those couplings, and now I could add new ones, etc. If you wanted to get the distance between lines that weren't adjacent to each other, then you'd want to use the manual mode. Again, use your pick on the peak, then hold down the shift and the command key while you simultaneously click on the other peak. So now I've selected this peak and this peak, so when I hit J, I'll get the coupling constant between those two, and you can see that's 14.2 Hertz. In this case, that doesn't correspond to a coupling constant, so I wouldn't be interested in it, but in a spectra where you have doublets and things like that, you might want to know what those distances are. So again, to get rid of them, hit your selection and select the peak. And any peak you want to delete, you can just delete manually that way. And you can, of course, add any peaks you want back by just clicking on them with your peak tool, and it'll add those peaks manually. So that's a convenient way to get the coupling constants. Again, then you could go back to your full spectrum. Oops. I'm sorry, I need to select the zoom cursor here, and then I can reset the view to home. So there it is. I could zoom in on this region and calculate the coupling constants for that. So it's just a very convenient way to sort of get coupling constants calculated. So that, I think, is all the main things that I wanted to show you, so you know how to sort of move around and zoom in on the various parts of your spectra. You know how to set the reference, you know how to put an integral on it, and you know how to get the peaks both in ppm and in hertz for coupling constants, so that you can do a full analysis of your spectrum. So I hope that's been helpful, and I want to show you one more thing. If you want to get deeper into the Delta program and learn more how it works, there's a whole large manual, as you might expect, and that manual, I've got a link to it on our Chemistry Techniques SoundNet site, which is from our Moodle site. If I click on that, it'll bring up the SoundNet site. You may have to enter your UPS password to get here, and then I can click on the NMR and Delta information. And there's instructions for installing, and there's also lots of instructions for using Delta. And in particular, I want to point out this Data Processing Manual version 5. If you click on that, it'll download a PDF file which has all of the instructions for using Delta and doing all sorts of fancy things. I'll show you right here. Here's an example of what it looks like, one of the pages out of that manual. It's hundreds of pages long, so there's lots of detailed instructions if you want to learn how to do fancier things like put a inset picture inside your spectrum, etc. But for now, I think that's enough to get you going where you can at least display and do some simple manipulations on your spectra.